In question 1, part 1, we have to expand 1 plus y to the power 6 in ascending powers of y as far as the term in y squared. So in the first step, we know that the formula for an expansion of 1 plus b to the power n is 1 plus nc1 b power 1 plus nc2 b to the power 2 and so on. So in this question, we have 1 plus y to the power 6. So this will be equals to 1 plus 6c1. This will become y to the power 1 plus 6c2 and y to the power 2. And as we just have to expand till the term in x squared, so we leave it till 6c2 y to the power 2. So 6c1 will become 6. This will become y to the power 1 plus 6c2. If we substitute this in the calculator, that is equals to 15. So that will become 15y squared. In part 2, it says in the expansion of 1 plus px minus 2x squared to the power 6, the coefficient of x squared is 48. We have to find the value of the positive constant p. Now, we have already expanded an expression of the form 1 plus y to the power 6, and the expansion was 1 plus 6y plus 15y squared. Now, in this question, in place of y, it has been replaced with 1 plus, and y has been replaced with px minus 2x squared. So we can replace the y as px minus 2x squared. So this will become 6 into px minus 2x squared plus 15 into px minus 2x squared. And this will become a whole squared. Now expanding this, we'll get 1 plus 6px minus 12x squared plus 15. And expanding this, we'll get p squared x squared. This will become minus 4 into, so this will become px cubed plus 4x to the power 4. Now, as we just need the terms in x squared, as the coefficient of x squared is 48, so we'll take minus 12x squared and plus 15p squared x squared. So we can write this as 15p squared x squared minus 12x squared, and that will be equals to 48x squared. Now, as we just have to compare the coefficients, so taking x squared common, we can write it as x squared into 15p squared minus 12 is equals to 48. X squared and x squared will cancel out. So we'll have 15p squared minus 12 equals to 48. So 15p squared will be equals to 48 plus 12, which is 60. P squared will be equals to 60 upon 15, which is equals to 4. And now taking the square root of 4, that will be plus minus 2. But as we just had to find the value of the positive constant p, so the final value of p will be p equals to positive 2. In question 2, the function g is defined by g of x equals to x squared minus 6x plus 7 for x greater than 4. By first completing the square, we have to find an expression for g inverse and state the domain of g inverse. Now, if we have to complete the square, what we do is first, the expression is x squared minus 6x plus 7. So we write x squared minus 6x in the brackets and write 7 outside. Now taking half of b, which is 6 in this case, and the coefficient of x squared is already 1. So we'll add and subtract half of b squared. So half of b is 3. So this we'll add 3 squared over here. And as we added 3 squares, we'll have to subtract the same amount from the expression. So this will become minus 3 squared plus 7. Now x squared minus 6x plus 3 whole squared is basically x minus 3 whole squared. And minus 3 squared plus 7. So minus 9 plus 7 becomes a plus 2. So minus 9 plus 7 is a minus 2. So this is g of x after completing the square. Now to find f inverse, we first write y in place of the function. So in this case, the function is g of x. So this will become y equals to x minus 3 whole squared minus 2. Now changing the values of x and y, this will become x equals to y minus 3 whole squared minus 2. Taking 2 on the left hand side, we'll get x plus 2 is equals to y minus 3 whole squared. Now taking the square root on both the sides, so we'll get y minus 3 is equals to the square root of x plus 2. And finally, taking 3 on the other side, so we'll get y equals 2 plus 3, and this will become plus minus square root of x plus 2. So we can write that the expression for g inverse of x will be equals to 3 plus square root of x plus 2. Now, we also have to state the domain of g, which means we have to find this x value. Now, whatever x value we take over here, this whole function, the g inverse function, must be greater than 4. as the domain of f, the original function g of x was x greater than 4, it means we need to find a value of x for which this whole function will be greater than 4. So to find the x value, we can write it as 3 plus x plus 2 must be greater than 4. So we can take 3 on the left hand side, and this will become x plus 2 is greater than 1. Taking the square on both the sides, we'll get x plus 2 is greater than 1. So x will be greater than 1 minus 2, which is minus 1. So the domain for G inverse will be x greater than minus 1. However, even we just by looking at the expression, we can see that 3 plus this number must be 1 or more. So taking minus any value less than minus 1 would result in this becoming less than 1, and the range of this G inverse function will become less than 4. And as the domain of the original function was greater than 4, it means this whole function G inverse of x must be greater than 4. So for only values of x greater than minus 1, G inverse of x will be greater than 4. So the domain of G inverse will be x greater than minus 1. Question 3, the equation of a curve is y equals to x cube plus x square minus 8x plus 7. The curve has no stationary points in the interval a to b. We have to find the least possible value of a and the greatest possible value of b. Now to find this, we'll still have to find the dy dx, as at a stationary point, the dy dx is equal to 0. So we can find the values of x for which the dy dx is 0, and the values of a and b will be in between those values. So first finding the dy dx, that will be equals to 3x squared plus 2x minus 8. And now putting dy dx equals to 0. So the values of x will be 3x squared plus 2x minus 8. Factorizing this, so we'll get 3x squared plus 6x minus 4x minus 8. Taking 3x common, we'll get 3x into x plus 2. So this will become 3x into x plus 2 minus 4 into x plus 2. So the values of x will be 3x minus 4 and x plus 2 equals to 0. So the values of x will be x equals to 4 upon 3 and x equals to minus 2. Now, in the question, it says there are no stationary points in the interval x greater than a and less than b. Now, we know that the dy dx, or the stationary point, will be at x minus 2 and x equals to 4 upon 3. So the greatest value of a, as x has to be greater than a and less than b. So the greatest possible value of a will be minus 2, as x has to be greater than the smaller value. So the value of a will be equals to minus 2. And as the highest value will be x equals to 4 upon 3. So b will be equals to 4 upon 3. And between these 2 points, there will be no stationary points, as the stationary points are at 4 and 4 upon 3 and minus 2. So between 4 upon 3 and minus 2, the curve will have no stationary points. In question 4, the diagram shows a semicircle ACB with center O and radius R. Arc OC is part of the circle with center A. In part 1, we have to express angle CAO in terms of pi. Now, we know that this is the radius of a sector and the center is A over here. This length is R, which means the length AC will also be equals to R. If we draw a line from O till C, so this will be the radius of the semicircle, which is also R. Now, as all the three lengths are equal, it means that each angle it is an equilateral triangle. As the total angle in a triangle is pi radians, so each angle will be pi upon 3. So the angle CAO will be equals to pi divided by 3 radians, and that will be the final answer for the angle CAO. Now in part 2, we have to find the area of the shaded region in terms of r, pi, and root 3, simplifying your answer. Now, to find the area of the shaded region, first we'll try and find the area of the triangle ACB, and then subtract the area of the sector CAO. Now, we know that this length AC is R, the length AB is 2R. So to find the length of CB, now as this is a semicircle and these 2 points are meeting at the point C, which is the circumference, so this will make a right angle triangle. We'll use a circle property, which is a right angle in a semicircle if the 2 points on the diameter are meeting at the circumference. So this makes a right angle. Applying Pythagoras theorem, so we can write that AB squared will be equals to AC squared plus CB squared. So AB squared is 2R whole squared. AC is R, so this will become R squared, and this will be CB whole squared. So CB squared will be equals to 4R squared minus R squared, which will be equals to 3R squared. And now finding the square root of CB, so CB will be equals to square root of 3R squared. We know that the square root of R squared will become R, so we can write this as square root of 3, and we can write R outside the square root. Now, once we have the length of CB, so we have the height and the base of the triangle. So the area of triangle, and the triangle is ABC or ACB, that will be equals to half base into height. The base is R and the height is root 3R. Root 3 R into R will become root 3R squared. So we can write this as root 3R squared upon 2, which is the area of the triangle. Now finding the area of the sector. So area of a sector is given by the formula half R squared theta. The radius is R, and we have to give our answer in terms of R, and the angles CAO was pi upon 3. So the area of this sector will become half into R squared. So this will become R squared into pi upon 3. We can simplify this to write it as pi R squared upon 6. Now to find the area of the shaded region, so the shaded region will be equals to the difference of the two areas. Okay, so this is not the correct spelling, shaded. So the shaded region will be equals to the area of the triangle, which was root 3R squared upon 2, minus the area of the sector, which is pi R squared upon 6. And as it said that we have to simplify our answer, so we can first take the LCM over here. Taking the LCM, which will be 6, so we'll get 6 in the denominator, and this will multiply by 3. So this will become 3 root 3R squared minus pi R squared. We can take R squared is common, so we can write the final answer as 3R squared 3 root 3 minus pi upon 6 as the area of the shaded region. In question 5, the dimensions of a cuboid are x centimeter, 2x, and 4x as shown in the diagram. We have to show that the surface area and the volume are connected by the relation S is equals to 7v to the power 2 upon 3. In the first step, we'll first find the volume of the cuboid. So the volume will be length into breadth into height. So that will become x multiplied by 2x into 4x, and that is equals to 8x cubed. So we can write V will be equals to 8x cubed, and the surface area will be equals to the 2 times multiplied by the base multiplied by height. So that will become 2x squared plus 2 times the width multiplied by height. So that will become 2 times 4x squared, and then 2 times the base multiplied by the width. So that will become 2x into 4x, which is 8x squared. So the surface area will be equals to 4x squared plus 8x squared plus 16x squared. Adding these three, we'll get the surface area as 16 plus 8, 24 plus 4, which is 28x squared. Now, as we have to prove that the surface area is 7 times V to the power 2 upon 3. So we know that the volume is 8x cubed. First, we can find the cube root of this whole thing, as this 3 in the denominator shows a cube root. So first finding the cube root of 8x cubed. So first finding V to the power of, this will become V to the power 1 upon 3. So V to the power 1 upon 3 will be equals to 2x. Now this 2 basically represents a whole square. So first we'll whole square both the sides. This will become V to the power 2 upon 3 is equals to 4x squared. Now, as the surface area was 28x squared, so we'll have to multiply this by the V to the power 2 upon 3 by 7. So multiplying both the sides by 7, this will become 28x squared. So 7v to the power 2 upon 3 is equals to 28x squared, which basically is the surface area, so we can write this as the surface area. So the surface area will be equals to 7v to the power 2 upon 3. In part 2, it says find the when the volume of the cuboid is 1000, the surface area is increasing at 2 centimeters square per second. We have to find the rate of increase of the volume at this instant. Now we already have a formula relating the surface area and the volume, which is 7v to the power 2 upon 3. S is equals to 7v to the power 2 upon 3. So the rate of change of these two will be related by the equation ds by dt will be equals to ds upon dv multiplied by, and this will be dv by dt. We already have the rate of change of the surface area, which is 2. So we have to find ds by dv. So first differentiating, so we have s is equals to v to the power 2 upon 3. So ds by dv will be equals to 2 upon 3 multiplied by 7. So that will become 14 upon 3 and v to the power. So 2 upon 3 minus 1. So that will become minus 1 upon 3. And we can write it as 14 upon 3. And we can write it as cube root of v. So as v is equals to 1000, so substituting v equals to 1000 over here, we'll get ds by dv will be equals to 14 upon 3 into cube root of 1000 over here. So cube root of 1000 is 10. So this will become 14 upon 3 into 10 or 14 upon 30, which we can simplify by dividing it by 2 and write it as 7 upon 15. Once we have ds by dv as 7 upon 15, so finding the rate of change of volume. So ds by dt is given as 2, the rate of change of surface area. ds by dv we found out is 7 upon 15 and multiplying it by dv by dt. So to find dv by dt, we'll multiply 15 by 2 and then divide by 7. So dv by dt will be equals to 15 times 2, which is 30. So this will become 30 divided by 7. And we can add the unit centimeter cube per second as well, but this final answer will be enough so that we can write centimeter cube and second minus 1. In question 6, a line has equation y equals to 3kx minus 2k and a curve has equation y equals to x square minus kx plus 2 where k is a constant. In part 1, we have to find the set of values of k for which the line and the curve meet at two distinct points. Now, if we have an unknown constant and a quadratic equation, it means we'll have to use the discriminant, which is b squared minus 4ac. And as the line and the curve are meeting at two distinct points, so it will be greater than 0. Now, in the first step, we'll equate the equation of the curve, which is x squared minus kx plus 2, and equate it to the equation of the line, which is 3kx minus 2k. So now taking it on the left-hand side, we get x squared minus kx minus 3kx plus 2 plus 2k, as this will become a plus 2k, and it will be equal to 0. So minus kx minus 3kx will become minus 4kx, and this will remain 2 plus 2k equals to 0. So the coefficient of x square is 1. So a will be equals to 1. The coefficient of x is minus 4k, and the constant term c will be equals to 2 plus 2k. Now applying b squared minus 4ac, so this will become minus 4k whole squared, b squared minus 4 into 1 into c, which is 2 plus 2k, and we'll put it greater than 0. So expanding 4k squared, that will become 16k squared. This will become minus 8, and this will become minus, so 4 times 2 will become an 8k, and this will be greater than 0. We can divide this equation by 8 and rearrange it to write it as, so this will become 2k squared minus k minus 1 and greater than 0. Factorizing this, we'll get 2k squared, and this will become minus 2k plus k minus 1 greater than 0. Now taking 2k common over here, we'll get k minus 1, and taking 1 common over here, we'll get k minus 1 greater than 0. Simplifying this, this will become 2k plus 1 and k minus 1 as greater than 0. Now we have to give the correct inequality sign for the values of k. So to understand this, we'll again make a quadratic curve. So the upper value is k equals to positive 1 and the lower value is minus 1 upon 2. Now as b squared minus 4ac is greater than 0, so we'll move towards the left from minus 1 upon 2 to have the curve as greater than 0, as it is greater than 0 above the x-axis. So k will be less than minus 1 upon 2, and moving towards the right from the value of k equals to 1, the curve will be greater than 0, so the other value will be k greater than 1. In part 2, it says for each of the two particular values of k, the line is a tangent to the curve. Show that these two tangents meet on the x-axis. Now the equation of the line was y equals to 3kx minus 2k. So the equation was y equals to 3kx minus 2k. Now we have the values of k. The two values were k equals to 1 and the other value was k equals to minus 1 upon 2. So substituting these values, substituting 1, we'll get one of the equations of the tangents as 3 into 1. So that will become 3x minus 2 into 1. So that will become 2. And substituting, so in this case, we substituted k equals to 1. And now substituting k equals to minus 1 upon 2. So this will become y equals to 3 into minus 1 upon 2 into x minus 2 into minus 1 upon 2. Simplifying this, we'll get y equals to minus 3 upon 2x plus 2 upon 2. So that will be equals to plus 1. Now, as we have to show that these two tangents meet on the x-axis, so what we'll have to do is we'll have to find the points of intersection. And if it is on meeting on the x-axis, it means that the y-coordinate will be equals to 0. So first, equating the two equations, we can find the value of x. So this will become 3x minus 2 is equals to minus 3 upon 2x plus 1. Taking 3 upon 2x on the left-hand side, we'll get 3x plus 3 upon 2x is equals to 1 plus 2, which is equals to 3. Now taking the LCM over here, so this will become 6x plus 3x upon 2 equals to 3. Simplifying this, we'll get 9x is equals to 6 and x will be equals to 6 upon 9, which is equals to 2 upon 3. Now, once we have the value of x, we'll have to see that the y value should be equal to 0. So using one of the equations, which was 3x minus 2, so y will be equal to 3 into 2 upon 3 minus 2. 3 and 3 will cancel out. 2 minus 2 will become a 0. So y will be equal to 0. So this value of y shows that the two tangents are meeting at the x-axis. In question 7, part 1, we have to show that the equation 3 cos to the power 4 theta plus 4 sine square minus 3 equals to 0 can be expressed as 3x square minus 4x plus 1 equals to 0, where x equals to cos square theta. So as we have to bring it in terms of cos square, x is representing cos square. So we can first use the identity where cos square is equals to 1 minus sine squared, or we can also write it as sine squared is equals to 1 minus cos squared. So in the equation, we can first write it as 3 cos to the power 4 plus 4 into, so in place of sine square, we can write 1 minus cos squared minus 3 equals to 0. Expanding this, we'll get 3 cos to the power 4 plus 4 minus 4 cos squared, and this will remain minus 3 equals to 0. Simplifying this, we'll get 3 cos to the power 4 minus 4 cos squared, and 4 minus 3 is a plus 1 equals to 0. Now, as cos squared is equals to x, so cos to the power 4 will become x squared. So this equation can be written as 3x squared minus 4x plus 1 equals to 0. In part 2, it says, hence solve the equation 3 cos 4 plus 4 sine square minus 3 equals to 0. Now, we have already shown that this equation can be written as 3x square minus 4x plus 1. So this is 3x square minus 4x plus 1 and equals to 0. And we know that cos square is equals to x. So first, solving this equation, we'll get 3x square and we have to get a minus 4. So this will become minus 3x minus x plus 1 equals to 0. Factorizing this, we'll get 3x in bracket x minus, so this will become x minus 1. And taking 1 common over here, this will become x minus 1 equals to 0. Simplifying this, we'll get 3x minus 1 and x minus 1 equals to 0. So x will be equals to positive 1 and x will be equals to 1 upon 3. Now, as we know that x is equals to cos squared, so we'll write cos squared of x is equals to 1 and cos squared of x will be is equals to 1 upon 3. So cos squared of x will, we can write it as cos x will be equals to square root of 1, which is 1. And over here, cos x will be equals to square root of 1 upon 3. So first finding the basic angle by taking cos inverse of 1. So cos inverse of 1 is equals to, so in this case, the basic angle will be equals to 0. And taking cos inverse of 1 upon 3. So in this case, the basic angle will be is equals to, so that will be equals to 54.7 degrees. Now, as the domain is from 0 till 180, so first we'll make the quadrants over here. And as the range is from only till 0 till 180, so cos is positive in the first quadrant and negative in the second quadrant. And as it is a square root over here, so we'll be able to take both the positive and the negative values. So we can first make the 0 in the first quadrant so that the angle in this case will remain as 0. So one of the values of theta will, so that is theta over here. So one of the values of theta will be equal to 0. And making this angle 0 in the second quadrant, which is the negative quadrant. So the second angle will be equals to 180. And when we take the basic angle as 54.7 in the first quadrant, so this angle is 54.7. So we'll have another angle for theta, which is 54.7 degrees. And making 54.7 the basic angle in the second quadrant, as we can also take the negative values due to the square root. So the last value we can take is 180 minus 54.7 degrees, which will be equals to 125.3. So the final answer for the values of theta will be equals to 0. It will be equals to 54.7. It will be equals to 125.3, and it will be equals to 180. In question 8, a function f is defined for x greater than 1 upon 2 and is such that f dash of x or f derivative of x is equals to 3 into 2x minus 1 to the power half minus 6. We have to find the set of values of x for which f is decreasing. Now, when it says that the function f is decreasing, it means that the derivative is less than 0. So we know that the expression for the f dash or dy dx is 3 into 2x minus 1 to the power 1 upon 2 minus 6. And it will be taken as less than 0. Taking 6 on the other side, we'll get 3 into 2x minus 1 to the power 1 upon 2 as less than. So this will become a positive 6. And then dividing 3 on the right hand side, that will become 2x minus 1. The power 1 upon 2 is less than 6 upon 3 will become a 2. Now whole squaring both the sides, so we'll get 2x minus 1. So when we whole square, this will become 4 and this square root will cancel out. So 2x minus 1 will be less than 4. Taking 1 on the right hand side, that will become 2x is less than 5 and x will be less than 5 upon 2. Now, as the value of x has to be greater than 1 upon 2, so the set of values of x will be greater than 1 upon 2 and x will be less than 5 upon 2. In part 2, it says it is now given that f of 1 is equals to minus 3. We have to find f of x. Now, this means if we have an expression for f of x, we can substitute x equals to 1 and put it equals to minus 3. Now, first using the expression for the derivative, which was 3 into 2x minus 1. So this was 3 into 2x minus 1 to the power half minus 6. Now we'll integrate it to get an expression for f of x. So integrating f dash of x, that will become f of x will be is equals to. So when we integrate, we increase the power by 1. So that will become 3 upon 2. We will divide it by the new power, which is 3 upon 2, and also multiply it with the derivative of 2x minus 1, which is 2. So 2 and 2 will cancel, 3 and 3 will cancel, and integrating minus 6, so that will become a minus 6x. And we'll add a constant over here, that will be a plus c. So f of x will be is equals to 2x minus 1 to the power 3 upon 2 minus 6x plus c. Now to find the value of c, we have that when f of 1 is equals to minus 3. So it means when x is equals to 1, the function will be equals to minus 3. So this will become minus 3 is equals to 2 into 1 minus 1 to the power 3 upon 2 minus 6 into 1 plus c. So this will be minus 3 is equals to, so 1 to the power 3 upon 2 will be 1 minus 6 plus c. So minus 3 is, and this 1 minus 6 will become a minus 5. When you bring it on the left hand side, that will become a plus 5 is equals to c. So c will be equals to positive 2. Once we have the value of c, we can write f of x as, so f of x will be is equals to 2x minus 1 to the power 3 upon 2 minus 6x plus 2. In question 9, the first, second, and third terms of a geometric progression are 3k, 5k minus 6, and 6k minus 4. We have to show that k satisfies the equation 7k squared minus 48k plus 36 equals to 0. Now we know that when it is a geometric progression, the common ratio is is a constant, and we find it by dividing two consecutive terms. So if we divide 5k minus 6, the second term, divided by the first term, which is 3k, it will be equal to, if we divide the third term by the second term, so that will be 6k minus 4 divided by 5k minus 6. So cross multiplying, we'll get 5k minus 6 multiplied by 5k minus 6, so that will become a whole squared, and 3k will multiply by 6k minus 4. Expanding this, we'll get 25k squared, so a squared minus 2ab, so that will become 6 times 5, 30 times 2, which will be a 60k, plus 6 squared, which will be 36, is equals to 18k squared minus 12k. Simplifying this, so when we bring 18k squared on the left hand side, that will become 25 minus 18, so that will become 75k squared minus 60k, and this will become a plus 12k, so that will become minus 48k, and the plus 36 will remain as it is, equals to 0, which is the equation that we had to prove. In part 2, it says, find, showing all necessary working, the exact values of the common ratio corresponding to each of the possible values of k. Now we have the equation for k, which is 7k squared minus 48k plus 36 is equals to 0. Now we can use our calculators to solve this equation. When we substitute these values in the quadratic equation of our calculator, so one of the values of k will be equals to 6 upon 7, and the other value of k will be equals to positive 6. Now for these values of k, we have to find the common ratio. Now the common ratio will be 5k minus 6 upon 3k. So we can use either of these two expressions. So using 5k minus 6 upon 3k, so the expression for the common ratio is 5k minus 6 upon 3k. Now using, in the first step, k is equals to 6 upon 7. So the common ratio will be is equals to 5 into 6 upon 7 minus 6 divided by 3 into 6 upon 7. So 5 into 6 is 30, and that will become 30 upon 7. So this will become 30 upon 7 minus 6, and this will divide by, so 3 times 6 is 18, that will become 18 upon 7. Taking the LCM in the numerator, that will become, so this is 1, so this will multiply by 7. So we'll get 30 minus 42, so that will become 30 minus 42 upon 7, and that is dividing by 18 upon 7. When we bring the multiplication sign, the 7 and 7 will cancel out. So the final answer we'll get is, so 30 minus 42 is minus 12, and upon 7 multiplied by 7 upon 18. 7 and 7 will cancel out. So one of the values of k will be is equals to, or the common ratio, as we already had the value of k. So the common ratio will be is equals to minus 12 upon 18. So minus 12 upon 18, and when you simplify this, one of the values of the common ratio will be minus 2 upon 3 if we divide it by 6. Now using k equals to 6, so substituting k equals to 6 into the same expression, that will become 5 into 6 minus 6 divided by 3 times 6. So 30 minus 6, that will become a 24, and this will become 18. And now dividing it by 6 again, so this will become 4. So 6 times 4 and 6 times 3. So the second value for the common ratio, that will be 4 upon 3. And the first value was minus 2 upon 3. Now in part 3, it says that one of these ratios gives a progression which is convergent. Find the sum to infinity. Now for a progression to be convergent, the common ratio must be greater than minus 1 and less than 1. So from the two values of r, 1 was greater than 1, and so that this cannot be taken as the value of r for which a progression is convergent. So we'll take this value of r, which is minus 2 upon 3. So first the value of r will be minus 2 upon 3. And a convergent sequence basically means that if we, let's say, if the first term is 1 and the common ratio is less than 1, so let's take it as half. So this sequence will keep on decreasing, keep on dividing by 2, but will never reach 0. It will keep on decreasing to a very small value. So this kind of a sequence is called a convergent sequence. Now, if for r is equal to minus 2 upon 3, the first term was, let's say it was 3k. So a will be is equals to 3k. So that will be 3 into, so the value of k that we got was 6 upon 7, for which r was minus 2 upon 3. So substituting 6 upon 7 over here, the first term will become 18 upon 7. To find the sum to infinity, the formula is a divided by 1 minus r. So the value of a is 18 upon 7, and the 1 minus r will become 1 minus r, so r will be minus 2 upon 3. Simplifying this will become 18 upon 7, and that will divide by 1 plus 2 upon 3. Taking the LCM for 1 plus 2 upon 3, so that will become 5 upon 3. So 18 divided by 7, 18 upon 7 will divide by, so taking the LCM, that becomes a 5 upon 3. Now taking the reciprocal, so that will become 18 upon 7 multiplied by 3 upon 5. 18 times 3 is 54, 54 and 7 times divided by 35. So this will become 54 divided by 35, which will be the sum to infinity, or we can give it in decimal as 1.54. So the sum to infinity can be written as 54 upon 35 or in decimal as 1.54. In question number 11, the diagram shows part of the curve y equals to x minus 1 to the power minus 2 plus 2, and the lines x equals to 1 and x equals to 3. The point A has coordinates 2, 3. The normal to the curve at A crosses the line x equals to 1 at B. In part 1, we have to show that the normal AB has equation y equals to half x plus 2. Now to find the equation of the normal, we'll first have to find the gradient of the normal. For that, first we find the dy dx of the curve. So the dy dx of the curve will be equals to, so we'll multiply minus 2 by the coefficient. So that will become minus 2 into x minus 1 to the power minus 3. Multiplying it with the derivative of x minus 1, this will be 1. And the derivative of 2 will become a 0. So the dy dx can be written as minus 2 upon x minus 1 whole cube. At point A, the x value is 2. So when x is equals to 2, dy dx will be is equals to, so that will become minus 2 upon 2 minus 1 whole cube. So 2 minus 1 is 1, and minus 2 divided by 1 will be minus 2. Now this dy dx represents the gradient of the tangent, so that is minus 2. If the gradient of the tangent is minus 2, it means that the gradient of the normal will be a negative reciprocal, which will be positive 1 upon 2. Now to find the equation of the normal, we'll use the formula for the equation of a line, which is y minus y1 is equals to m into x minus x1. So y1 is 3 as given in the question. So this will become y minus 3 is equals to 1 upon 2 into x minus the x1 value will be taken as 2. Now expanding this, we'll get y minus 3 will be is equals to, so we can write this as half x minus 2 upon 2, which will become 1, and minus 3 will go over on the right hand side and become a plus 3. So the final equation can be written as given in the question, y will be equals to 1 upon 2x, and minus 1 plus 3 is a plus 2. Now in part 2, it says find showing all necessary working the volume of revolution obtained when the shaded region is rotated through 360 degrees about the x-axis. Now the formula to find the volume is given by the formula pi multiplied by the integral of y squared dx and the limits b and a. So we can now divide this curve to find the volume of the shaded region. We can divide it into two parts. We know that this coordinate will be 2. So we can first find the volume under the line and then the volume under the curve, and then add the two volumes to get the volume under the shaded region. Now we already have the equation of the line, which is half x plus 2. So to find the volume under the line, the volume will be is equals to, so we'll write volume will be equals to half x plus 2, and that will become a whole squared dx, and the limits will be the upper limit, which will be 2, and the lower limit will be 1. And we'll add pi to the final answer once we have applied the limits. Now in the first step, we have whole squared it. Now we'll have to integrate it. So when we integrate this will become half x plus 2. The power will increase by 1, and we'll divide it by the new power, which is 3. And also we'll divide it by the derivative of half x plus 2, which is half. So 3 will multiply by half, and that will become 3 upon 2. So we are dividing this by, so this we can write it as 3 upon 2. Now when we bring in the multiplication sign, so that will become 2 upon 3. So that the integral will become 2 upon 3 into 1 upon 2x plus 2 to the power 3. Now once we have integrated this, we can apply the limits. So the limits are 2 and 1. So applying first x equals to 2. Into this equation, we'll get 2 upon 3 multiplied by, so that will become 1 upon 2 into the x value is 2 plus 2 to the power 3. And then applying the lower limit, which is x equals to 1. So that will become 2 upon 3 into half into 1 plus 2 to the power 3. So 2 and 2 will cancel out over here. This will become 1 plus 3, which is, so 1 plus 2, which is 3. 3 cube is 27, and 27 times 2 will become 54. So this will become 54 upon 3, and this will subtract from the lower limit. So this will become half plus 2. So half plus 2 is 2 whole 1 upon 2, or 5 upon 2. And we can write it as 2 upon 3 into 5 upon 2 whole cube. Simplifying this, we'll get, so 5 cube is 125. 125 times 2 will become 250. So this will become 54 upon 3 minus 250. 2 cube is 8, and 8 times 3 will become a 24. So 54 upon 3 is 18, and 18 minus 250 upon 24. So taking the LCM, we'll get, so this will be 1 over here, and this will multiply by 24, and this will multiply by 24 as well. So simplifying this using the calculator, so we'll get 18 multiplied by 24. So if we substitute this in the calculator, this will become 18 times 24, which is 432 minus 250. That is, okay, so that will become 18 times 24 minus 250. So that is 432. 432 minus 250, that is equals to 182 upon 24. And if we substitute 180 upon 24 in the calculator, that will become 91 over 12. So we can add pi to this answer now. This is 91 upon 12 pi, which is the volume under the line. Now, once we have the volume under the line, to find the volume under the curve, we'll again use the same formula, and we'll use the equation of the curve. So the equation of the curve was y equals to x minus 1 power minus 2 plus 2. So this was x minus 1 to the power minus 2 plus 2. So we'll have to first whole square this and apply the limits. So the limits in this case will be 3 and 2. As we can see over here that the upper limit is 3 and the lower limit is 2. So now first expanding, because there's a whole square, so we can apply the formula a squared minus 2ab plus b squared, or a squared plus 2ab plus b squared. So a is x minus 1 to the power minus 2. That will become, so expanding this, that will become x minus 1 to the power minus 4 plus 2 into 2. So that will become 4. So this will be 4 into x minus 1 to the power minus 2 and plus 2 squared, that will be equals to 4. Once we have expanded this, now we'll have to integrate this. There is still integration sign over here with the limits 3 and 2. Now integrating x minus 1 to the power minus 4, that will become, so we'll increase the power by 1, that will become minus 3. We'll divide by the new power, which is minus 3. Then integrating x minus 1 to the power minus 2. So we'll increase the power by 1 and divide by the new power, that is minus 1. And integrating 4x, that will become 4x. Once we have integrated, we can simplify to write it as minus 1 upon 3 into x minus 1 whole cube minus 4 upon x minus 1 plus 4x. And now we can apply the limits. So the upper limit was x equals to 3. So this will become minus 1 upon 3 into 3 minus 1 whole cube minus 4 upon 3 minus 1 plus 4 times 3. So that will be equals to 12. So now simplifying this, before we substitute the lower limit, we'll get minus 1 upon, so this will be 3 times 2 cube 8 minus 4 upon 2. So that will be 2 plus 12. Minus 2 plus 12 is plus 10. So we can write this as 10 minus 1 upon 24. And simplifying this by taking the LCM, that will become 240 minus 1, which is 239 upon 24. And now applying the lower limit. So the lower limit was x equals to 2. So applying x equals to 2 into the equation, we'll get minus 1 upon 3 into 2 minus 1 whole cube minus 4 upon 2 minus 1 and plus 4 times 2, which is 8. So 2 minus 1 is 1, 1 cube is 1, so 1 times 3, so this will become minus 1 upon 3, and minus 4 upon 1, so that will become minus 1 upon 3 minus 4 plus 8. 8 minus 4 is 4, so this will be 4 minus 1 upon 3. This will become 3 times 4, 12. 12 minus 1 is 11 upon 3. So once we have these two values for the upper and the lower limit, to find the volume of the shaded region, we'll subtract these two values. So that will become 239 upon 24 minus 11 upon 3. So if we substitute this in the calculator, that will become, so this is 239 upon 24 minus, and that is 11 over 3. So that is equals to 151 over 24. And once we have this answer, we can find the volume of the shaded region by adding the volume under the line. So the shaded region will have a volume of 151, and they will have to add a pi over here. So 151 upon 24 pi plus the volume under the line, which was 91 over 12 pi. Substituting this in the calculator, so we have 151 over 24, and we'll add it to 91 over 12. So the final answer will become 111 over 8 pi. So that is 111 divided by 8 pi as the volume of the shaded region.